Alrighty. Okay. Hi, welcome. Happy Labor Day weekend. Thank you for being here. So some reminders. Who here has submitted Lab 1? I think we're good. Who here is still working on Lab 1? Who here is completely lost on Lab 1? No one's completely lost on Lab 1. Yay! If you are completely lost or if you have super weird errors, come talk to me. I'm available after class. I'm reserving this time. We might walk down over to my office. So yeah, so anyone who's having issues and wants to talk afterwards, come with me and we'll go over there. If you're not available after class, just send me an email and we'll find a time. I think that's it. I wanted to show you how you're going to grade yourself on the labs. So lab 1 is going to be a little bit different in that we also have the birthday.java file. But in general, let me make this its own window. So this is pretty much what you should see when you're working on the lab. This is your IDE. And so let's say you're done working on birthday, child credit, and all that. You're done working on it and you want to see how you did. So you're going to open the test folder and let's say the child credit tests. So this is the why isn't it working? Okay. Okay, so yeah, so it opened this child credit test and there's all this code that does something. And so what it's doing is it's basically testing, are the results of your code the same as what is expected? And so for this example, so to run all the tests, I will hit the, let's see, there's usually like a play button over here on the left-hand side when you open this code. If I click it, then either you get, okay. So what happened here was this code I just downloaded from GitHub. And so it's like I haven't done anything in it. So we would expect that this code not passes the test, right? Because I haven't done anything. Let me see. Give me just a second and I will find. I think that's it. Okay, I might be wrong, but let's see. Okay, so okay, this is the solution. Great. So okay, so when I run the child credit test, it's either going to give me an X, which means some of the test cases didn't pass, or it's going to give me a check mark to say the test passed. So this one is the solution. So I expect all of these tests to pass. And so the way you get it, see which ones passed, is you come out to some terminal window. If it's not visible, there should be 3 dots, and you can go to the test results. The test results are what we care about for this. And then on the right-hand side, it says, here's the result of all these tests that I just ran. So for me, for the child credit test, since it's the solution, all of them worked. So the output matched what was expected. For the natural tests, I can go through and I can click the play button here and it says, here's my new test run. And all of those tests worked. And so your job is, if you run the tests for all the test files that are provided and you get all check marks, good to go, 100%. If you miss some of the tests, if some of them are X when you turn in the code, then I'll deduct a proportional number of points. So you want green check marks all across the board. If some are red, then you'll just get some points deducted. But it should be, I would like to give everybody 100% on a lab. So just make sure that if all your test cases pass, then you're good to go. Any questions on that? Okay, so once you're done with your lab, zip it, turn it into Canvas, and then what I'm gonna do is I'm gonna download your lab, unzip it, and then I'm gonna run like the child credit tests, natural tests, and statistics tests. And if those all pass, then you get 100%. Are we clear on the expectations for that? Is anyone having trouble running the JUnit tests? Okay, we've chatted. We will continue to chat. Okay. Okay. If that's good, great. Okay, so the other announcements that I have, we're having this thing called Club Galileo, where all of the math majors, the computer science majors, and physics majors, so all of the majors that are in Galileo, and if you're not a major, you are also invited. There's an ice cream social tomorrow, 1:30 to 2:30 in Galileo 116, which I believe is the math lounge. I'm not sure. That sounds right, but it could also just be some random room. So yeah, come out, have ice cream. Talked about how to grade yourself. Any questions, comments, concerns, problems before we get started? Okay. What I'll do today is if you submit your lab before like, I don't know, 5 o'clock, I'll try and go through and grade it and see how well you did. And then I'll put a comment in there like, hey, some of these didn't pass. So you'll know like if you did everything right or if there's things you need to fix. I'll try to do that by 5 p.m. Depends on how many questions I have afterwards. Okay. All right, so we're done with chapter 1. Let's see where we're at in the course. Where's student view? There we go. All right, so we're done with chapter 1. Now we're going to work on chapter 2. The chapter 1 worksheet is just there if you want extra practice. Sometimes I assign it as active learning, but not this time. Okay, so we're on to chapter 2. And if we go to the slides. So far we've been talking about primitive types. You know, those are the ints, the doubles, the chars, the booleans, the really simple types of variables. And now we're going to get into something a little bit more complicated, which we call reference types. And so the thing to know about reference types, reference variables, they're basically any type of variable other than primitives. So Java allows us to define our own types. We can just make up whatever type we want and then implement that and use it in our code. And so that's a reference type, a reference variable. So we don't really need to know all of the things that's going on here, but just so you know, like kind of how it works. So a primitive variable has a value, like an integer has a value of 6 or 10,000. Double has a value of 4.3. Like it has an actual value. A Boolean has a value of true or false. Reference variables are more complicated. So for here, I also, darn, okay, I need to set up the tablet. So I cannot use this today. So for reference variables, to kind of understand what we're doing here, we need to be aware of memory, the variables, and the actual data. So variables, so whenever we're doing coding and we have variables or things that we're storing information in, it lives in memory in our computer somewhere. So there's an address, and this information lives at some address on our computer in memory. And so that's what the part on the left is. So these numbers on the left, these are the addresses in memory of the 0.00 lives at location 1000 in memory, just for example. We also have variables, which us as the programmer, that's what we're looking at, where we've got so we've got variables called like 0.1, we've got a variable called 0.2, variable called 0.3. Those are our variable names that we as the programmer are using. And we've got the actual data that is associated with those variables. So like we have 0.1 equals 0, 0, and 0.2 equals 512. The 0, 0, and 512, that's the data associated with that variable. And so the point of this is to show you that so for primitives, if we had, man, I really wish I could write. So like if we had int 5 or something. So for primitives, the value lives in memory, and it knows like if we called this variable x, it knows that x equals 5, and it's stored in that one place in memory. With reference variables, we have to go like one link further. So we've got over here, we've got 0.1, that's a variable name. And we know, so for this one, we say the data associated with 0.1 lives at location 1000. So to go to the actual data stored for that variable, we have to go to a different memory location. That's pretty much it. It's a little bit complicated, but all this to say, reference variables work differently in memory than primitive variables do. So the reference variable stores a memory address where the actual data, the object, is. And so that's why we have like 0.3, or let's go with 0.2. 0.2 is at location 1024, and that's where the actual data 512 is. So there's one layer of separation there. So because of that, when we're working with like a reference variable, if we call it A and we have another reference variable C, we can't like multiply those two variables together because it's not clear what that means. Because if like A points to location 1000, C points to location 1024, when you multiply them, what does that mean? I don't know. It's unclear. So usually something like this is not allowed. So we can't do like arithmetic with it without defining what this arithmetic means. In C, if you've ever taken C, you're allowed to play with references. Not here. In Python, you didn't work with references, so it also doesn't really matter. Yeah, so with all that, let's try and make an example so we can actually have something concrete to talk about. So we're going to make our own type, and we're going to call it house. So I'm going to make a type house. So let's go to VS Code, and I'm going to go to my, not that one, this one, my in-class project. And I'm going to do Command-Shift-P and new Java file. And then I'm going to make a new class. And my class name is going to be capital H house. Capital H matters. Okay, so then when I press enter, I'll get over here, public class house. Give me a thumbs up when you get there. Okay. All right. Okay, I'll let the rest of you catch up. Okay, so we've got our house, and now we're going to put stuff into this file. So a reference type, we also call it an object. So we're coming up with this new type. We're defining whatever we want. We can do whatever we want here. So for me, I want to make a house. And so in this class, there are things that I want to be able to do. And there are things that I want to be able to keep track of. So for my house type, I want to be able to do things with my house, and I want to be able to keep track of things for my house. So maybe I want to keep track of, I don't know, the address of the house. And so I'm going to say, I'm going to have a variable that is of type string, and it's going to hold, this is the address of my house. And let's say I also want the number of stories in my house. How many floors do we have? There's a lot of other things I could do, but I think for this example, these two are sufficient. So for my house, I want to be able to keep track of what's the address, how many stories is it? In terms of things I want to do, I'll put this in comments and we'll add the code in a bit. So let's say I want to be able to add a floor to my house, because this is code and we're not bound to the laws of physics and construction. Yeah, question. Zoom. Here, let me. Is that good?
Yes.
Okay. Okay, so I want to be able to add a floor. Maybe if I want to add more than one floor. And I want to be able to get how many stories is my house. So there's a lot more I can add, but those are the main things that I want to do. Okay, so when we define a reference type, we have to have a constructor. And so we'll talk more about constructors. The thing with learning Java is we can either approach it from like, how do you do basic things in Java and then look at object-oriented programming, which is what we do in this class, or we can look at object-oriented programming and kind of flail around a bit until we learn how to actually do things in Java. So we'll talk a lot more about what each of the things that we're doing means when we get into object-oriented, but we're going to have some familiarity with it now. So if you're a little bit lost as we go through this, that's fine. That's normal. We'll get there. Okay, so we need a constructor, which is actually going to create the object for us. So we're going to have a constructor that defines basically like, here's the address, here's the number of stories. And I think there's I bookmarked this page. CTOR. So if I type CTOR, it makes some code for me that I could have also just typed very quickly. It says public house, capital H. And it looks a little bit like a method, right? Because it's got the public, it's got some name, and it's got parentheses. It's not really a method. It's a constructor, which is a separate thing, but it looks a little bit like it. But the important thing is we do not and cannot have void here. So like a void method just returns nothing. A constructor is not a method, so we can't have void. So if we said void, that would make this incorrect. Okay, it gave us the line super. I'm going to delete that. Let's not worry about that for now. If you have it, it's fine. Okay, so for our house, we're going to take in the address and the number of stories. I'll just call them string A and int S. And my constructor looks like address equals A and num stories equals S. And so then I can say, let's print house at this address has, and then I'll print num stories. Okay. Maybe I'll zoom out a little bit so you can see that. I want to close. Does anyone know how I can close like this left-hand side panel? I forgot what it's called. Oh, well, okay, that works. Yeah, okay, so we've got our constructor. So we say house and we take in two parameters, A and S, and we just set those equal to these variables up here that this is the data that we want to keep track of. And we print some information. The house at this address has this many stories. And then for our methods, we're going to add methods to this class. So we're going to have add floor. So we'll say public void add floor. In this case, void is warranted because we want to have a method and we want that method to return nothing. So our return type up here is void. So for add floor, all we want to do is add 1 to the number of stories. And maybe print the house now has this many stories. Just to make sure the user knows that we did something. Question, yeah. The public void. Wait, can you ask your question again? Right, so this is a method. So this is something, this is a structure that does something when we run this code. And so public, we'll talk about that. That just means that anyone can see it, any code can see it. Void means we are returning nothing. So like in other methods, like for hello last time, we were returning a number, an integer for the min function. And so we said this return type is int. For here, we don't want to return anything. We just want to add 1 to the number of stories. And so our return type is void, which means we return nothing. We can do something similar for add floors. So we can say public void add floors. and maybe the user gives us some integer. So we can add 1 floor, we could add 10 floors. And so we'll just do num stories plus equals I. So just however many floors the user wanted us to add to this house, now we've done it. And then I'll copy and paste this line so that we also print, here's how many stories we now have. Okay. And then for our last method, public something, num stories. And let's say we want to return the number of stories that our house has. What should go here as the return type? What do you think? Yeah. What should our return type for num stories be? What do you think? Yeah. Yeah. So num stories is a variable. We've declared it up here where we said this variable is of type int. And so if we're returning that variable, it makes sense that our return type would be int. So integer. All right. Good to go? Okay. Sorry, say that again.
I have a question.
Yeah.
Have you ever created num stories under a method and you can just like return it? Because it's a variable across the entire class. I forgot that's called, right?
Yeah, it's a field. And
so why wouldn't you just like return it at any point? Why do you?
Yeah, so that's a good question. Let's okay, so the answer to your question is sometimes we want to like have a wrapper, like a method where we just return this value instead of letting the programmer like access that variable directly and risk doing things to it that we don't want to be possible.
Well, actually, because like, if you just like return num stories in like another method, you could potentially edit the value.
Kind of. Let's do a test and see how that works. All right, I'm gonna go to another page. Okay, I'm gonna make a new Java file. We're gonna do this a lot. I'm making a new class. And my class name is called House Driver. So capital H house, capital H driver, and enter.
You can join.
Okay. All right, and so then I'm going to add a main method. So this is a driver file. A driver file is something that is designed for me to just run. It's like the statistics demo in your lab where you run the demo file and that's what actually does something. You've got the code that you've defined somewhere else in a different file, but the demo, the driver file, that's what you run to get something done. Okay, so one of the shortcuts to create a main method is PSVM, or I could also just type main. Either one of them gets you to this public static void main. And we're going to test out our house. So let's say we're going to make a variable and let's say, let's call it SMC. And we're going to say new house. And my address is 1928 St. Mary's, oops. I forgot, we need double quotes. So 1928 St. Mary's Road, and I don't know, let's just say we have one story. Okay. So this is our first variable of type house. We created the type house all by ourselves, and now we're using it. Let's make another house. Let's call it home. And let's say we live on 123 Main Street. And let's say our house has 4 stories. Okay, so now we've got 2 houses, and let's just test out the things that we wanted to do. So in our house.java, we had 3 methods: add floor, add floors, and number of stories. So let's add a floor to St. Mary's College. And for home, let's add like 40 floors and make it a skyscraper. And then finally, let's print we're going to print the number of stories belonging to St. Mary's College. Okay, so in here, we'll talk a little bit about how that works, but basically, when we say the new, we need to have the new keyword when we're working with reference variables. So that creates space in memory for us we've got some data that we want to store in this object, and so we need the keyword new to be able to do that. Next, we've got the house keyword. That is important because this is calling the constructor. So when we say new house, that's going back to this file. It's calling this constructor, and it's doing whatever code we set up in here. So with there, it's going to take those 2 pieces of data that we gave it, the address and the number of stories, that integer, and it's going to set it equal to these variables that are doing things in the class. And then we print something. Okay, so we've got that. Let me save it and run it. And so it prints several things. So first it prints house at 1928 St. Mary's Road has 1 story. That's what the constructor does. The constructor prints something. House at 123 Main Street has 4 stories. That's also due to the constructor. And then we called add floor once for St. Mary's, and so it now has 2 stories. We called it for the home at 123 Main Street. We added 40 stories. And then finally we called the prints the number of stories, and it prints 2 for St. Mary's. Okay. Questions so far? Okay. In terms of things we can do, we can play around with the equality and assignment operators. So because we can't do arithmetic right now without specifying more information, we can use equality or assignment. So like we could make a new house. Let's call it ABC, and we could set it equal to SMC. And so that's saying, like, now we've got this variable ABC. Let me see. Normally I like to draw on the PowerPoint, but that thing's not currently working. Okay, so if we've got the SMC, this points to an object that has 1928 St. Mary's Road and one story initially, right? And so if we say ABC, ABC now points to this variable, which by proxy is now like the data associated with ABC is now 1928 St. Mary's Road. Yeah, okay. So okay. I'm gonna put it back down. I might put it up again. Okay, so if we're testing assignment, so we've assigned ABC to SMC or SMC to ABC. Assignment works right to left. So instead of ABC or instead of SMC pointing to ABC, it's the other way around. So ABC has the data associated with SMC. For equality, let's test something. Okay, so if I say ABC equals SMC, who thinks we're gonna have true? Who thinks that's true? Okay, some votes. Who think it's false? Okay, at least one person. Let's test it. True. Okay, I'm gonna introduce something and it's gonna get more complicated. Okay, so let's make, let's, we're gonna make a new house and its address is 1928 St. Mary's Road. And it has one story. So I'll actually name it copy of SMC. And now let's try. Now let's try to, so now we've got a house that has the same information, 1928 St. Mary's Road, one story. Who thinks, and then we're going to set these equal to each other. Who thinks it's going to be equal? Same data. 1928 St. Mary's Road, one story.
What did you say again from the beginning?
So we've got a variable copy of SMC. Its address is 1928 St. Mary's Road, has one story.
This is a trick question, this is false.
Same information as the variable SMC. Does anybody think it's going to be true? Man. Okay, let's test it. False. It is false. Well, why do you think? What's going on here?
They point at different objects.
Yes, they point at different objects. I wish I had not put that down now. So yeah, so what we did here when we said new house, that's located now in a different area of memory. So SMC and ABC are over here, and copy of SMC is in a different place. It's the same information, but they live in different places. So the thing with reference variables and the equals, it's all about does the memory locations align? Are the memory locations at the same place? If that's not true, then equals will return false, even if all the little information things match up. So I'll say, they're in different memory locations. You don't need to write this, but if it's useful for you, feel free. Even if the data is the same, they live in different memory locations. Yeah. So yeah, so SMC and ABC are true because they're pointing at the same memory location. But SMC and copy of SMC, because they're in different memory locations, are false. Okay. Yeah, so it's all about living at the same address in memory for those equals. Yeah, and so this is something where the equality, which is the 2 equal signs, and assignment, 1 equal signs, that matters. Okay, so in terms of terminology, I'm going to be talking about objects. An object is an instance of a non-primitive type. So anything that's not an int, not a char, not a double Boolean, that's a non-primitive type. So for example, the copy of SMC variable, that's an object. My ABC variable, that's an object. SMC, also an object. Those are instances of a non-primitive type. That non-primitive type is house. Like we've said before, primitive types are handled by values. Objects are handled by references. And we've used the dot operation to use a method that belongs to an object. So like when we called house dot, like SMC dot add floor, we used the dot operation to use that add floor method. So over here, we have SMC dot add floor. That add floor, we made it ourselves, and it came from this method that we wrote. Okay, and so declaring it is a little bit different. You saw we had to do like the house SMC equals new house. So that's a little bit different than saying just like int x. So declaring, instantiating, slightly different. A note about garbage. So Java has something called garbage collection. And basically, when we reach a point in our code, when we have an object, but it's not needed, then in theory, the JVM, the Java virtual machine, goes and it's like, here's all the things you can't reach anymore, deleting it, free up space. So the thing to kind of remember is once you've reached a point in your code where your object is unreachable, then just assume that it's gone. If you wanted to do manual garbage collection, you can. The JVM may not always agree with it. And you can say like, do garbage collection right now. And the JVM is like, no, I don't want to. So I think it's best to just let the JVM decide, okay, now I'm going to do garbage collection. I will say also that Java garbage collection is like its own area of research. One of my PhD advisors had like a bunch of research where he was looking into like the actual like garbage collection process. So if you're interested at all about like little programming language things, you can probably do research in it. But yeah, so yeah. Just be aware that garbage collection exists and is a thing probably going on in the background. In C, if you've ever done C, you had to do this manually. In Python, you didn't worry about it. So also don't worry about it here. Yeah.
Irrelevant, but I took programming 1 last year and it was all Python. Is there a
Yeah.
reason why programming 2 doesn't build upon that, and it's a different language?
Programming 2 is in Java because I think it's good for you to be able to learn different languages. Because if you go and get a job in industry, they're going to throw a language to you and be like, work in this language that you've never heard of. So if maybe Java's really well known in a lot of industries. I think like off the top of my head, like banking industries for one, depending on what company you go to. Knowing how to code in 2 different programming languages helps you learn how to code in a third. Yeah. Other question, Ankit?
Oh, yeah, well, kind of just to follow up on that, like a lot of people I've spoken to, like, have told me that Java is actually a dead language, or it's a dying.
You're speaking it on, please. Speaking it on.
Well, I mean, what's your take on that?
I don't think I agree. I think let's also save this discussion for another time.
Sorry, it was irrelevant.
All right. All right, so let's keep going. So this is just like a summary of what happens. So when we're doing assignments and you're working with primitive variables, the value itself is copied. So like if you're working with 2 ints, x and y, if you assign x equals to y, then the value is copied. For objects, the address is copied and not the object itself, not like the actual data. For parameters, if you pass parameters, the new reference isn't created. It's at the same location in memory. We'll do some testing with that. And then for equality, when you're dealing with primitives, if we test x equals y, it asks, are these values identical? But when we're dealing with objects, we do x equals y. It's going to ask, do they refer to the same location in memory? Okay. Any questions before we move on? Okay, let's move on to strings. So we've worked with strings. Those are the things in the double quotes. Let's test some things out. So we'll do some code and then we'll go over the slide. So I'm going to make a new class. I'm going to call it string testing. And I'm going to have a main method in there. Okay. So we can define strings like we have, like we did with house. So we can say string, I don't know, my new awesome string equals new string. And then in here, in the constructor argument, we can say whatever I want my string to be, hello or something. And so we've got, here's the type, the string over here on the left is the type. Then we've got the variable name. Then we've got the new keyword. Here's the type and the open parentheses. And then inside the parentheses, we just say, here's what I want my string to be. That's a little bit complicated way of doing it. We've also done it before, where we can just say string variable name, like string B equals 222 is a cool class. That's the simpler way of doing it. Either works to define our string. The reason it does is string is a really common type in Java, and so they've made it so that you can declare and instantiate it in multiple different ways. So it's well supported. We can do something like, let's print let's print the character at some location in my string. So say b dot char at, I'm gonna zoom out a little bit so that we can. Yeah. Char at, there we go. Let's get the character at position 7. So char at, that like looks at, it starts counting from 0. So 0, 1, 2, 3, 4, 5, 6, 7. So I think I'm expecting an A if we run this. And there we go. So the 7th character in the string 222 is a cool class is A, and that's what we get. We can concatenate 2 strings. So if we have 2 strings, we can smush them together. So let's say I want to concatenate my new awesome string and B to say, hello, 222 is a cool class. So I can say, let's just actually print the output. And so we'll say my new awesome string, and then the plus and B. And what do we think is gonna, it should just be hello, 222 is a cool class, right? We run that. Then we get hello, 222 is a cool class. No space there. Something interesting to know. If we wanted to add a space, in here we could say, we could add plus and then the string containing a space. And if we did that and ran it, then we get hello space 222 is a cool class. So if we just add 2 strings together, it doesn't add spaces automatically at all. It doesn't worry about that. It just smushes them together. We can also, let's say we want to add, I don't know, like 1,000,000 ellipses after hello. So we can say my new awesome string. We can say plus equals. So plus equals also works with strings. And just add like ellipses afterwards. And let's print what it looks like after that. So it's hello, dot, 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 dot. We could also have done my new awesome string plus equals B, because B is also a string. And so now, what's that going to say? Hello, dot, 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 dot. 222 is a cool class. That's my guess. And there we go. So we can concatenate strings together. We can also compare 2 strings. So one of the ways to do that is A dot compare to B. And compare to is a method that strings know about. Let me see. If I Google compare to Java and I go down to Oracle, Oracle is, that's where you want to go for the documentation for anything Java of like, what are the options for system.out or how does compare to work? You're going to want to go to the Java docs on Oracle's website to help you out for that. And so compare to looks at the lexicographic order. So that's the dictionary order. Wait, I want to go back here. And so when we have two strings, A and B, and when we call A dot compare to B, it's going to give us some result. So it's going to give us a number, and that number it has a magnitude, like the size of the number. It also says, it also has like negative, positive, or 0. So the result is that A is either less than. If it's less than, it's going to give you a negative number. If it's equal to, it's going to give you 0. Or if A is greater than B, it's going to give you a positive number. So it gives you ways to compare it gives you ways to compare A to B. So we're going to test that with E as capital H hello and F as lowercase h hello. If I look up so I'm going to tell you like a little bit why these answers are going to be different. Because if we say E dot compare to F, it's not going to be 0. And the answer why is if we look at a Unicode table. So I'm going to pull up maybe this is it. Okay, so okay, yeah, it is. So here on Wikipedia, we've got our list of Unicode characters. And as we scroll down, so we've got a decimal. There's a number for each Unicode character. And so like the capital H Unicode character is 72. After all the capitals and some of the brackets, slash and stuff, then the lowercase letters come. So like lowercase h is 104. So the capital letters show up before the lowercase letters. And so that's why if we run this, we get negative 32. So that tells us that E comes before F in dictionary order. Because in Unicode, capital letters, like the capital H, come before the lowercase letters. If we swapped them, it would be positive. So let's try F dot compare to E. Then we get positive 32 because F comes after E in the lexicographic order. Okay. Let's try something. Let's see. Let's say string H is hello. And so if F and H, those are both the same string, let's test something. Let's try to compare F and H. Who thinks this is going to be true? Who thinks this is, okay, some true. Who thinks this is going to be false? Okay, some true, some false. Let's try. It's true. Even though they're two, like we define it in two different places, arguably they live in different places in memory. It's true. The reason for this is because strings are so well supported in Java. They've written code so that if we do equals equals for strings, it'll give us it'll actually compare the contents of the string. So this is like our current exception. If we wanted to, for all of ours, we can say what equals equals means for this object. But yeah, so they've defined this so that we can use equals equals for strings. Don't expect this to work for all of the types that we work with. Okay, equals. There's another way to check equals that I would encourage you to use more than equals equals. And that is E dot or H. There's H dot equals what is it? F. So there's the dot equals method, and that's something that we know how to define. And we'll talk about what that exactly looks like later. But the dot equals is, the dot equals is another way to check for equality, specifically for reference variables. So equals equals works for primitives to check value. Dot equals works for reference variables to check for equality. So if I do that, I expect that also to be true. Okay, the other thing we can do with strings is we can parse it to another type. So let's say we have a string, I'll call it strpi, and it's the first two digits of pi, so it's 3.14. Let's say I've got this in, I don't know, maybe it's in a text file, and I want to convert it to a decimal that I can actually work with and do some math with. I can do that. So I'm going to say it's going to be a double, and the variable name is pi. And so I can get it into an actual double by saying capital D double dot parse double. And I give it, its argument is strpi, the actual string that I want it to parse. And then just semicolon. We'll talk more about what the capital D double is. It's like a wrapper, so it kind of wraps around this the double primitive type, and it says here's a reference type that I can do things with, like I can call parse double, and that gives me like a double that I can actually work with. If I want to do this with integers, instead of double dot parse double, I would say integer dot parse int, and then whatever the variable name is in there. Okay, questions on strings? Okay, strings are pretty straightforward. So I think we've gone over all of this. So we can use equals. Once we create a string, we can't change it. So we either, so like we can't say, let's try strpi dot, like we can't say, if I wanted to change a 3 to a 4, I can't do something like this. Like I can't change that. So strings are immutable. So if I wanted to change 3.14 to 4.14, I would need to either overwrite that variable or make a new one. So I could say string pi is now 4.14. That's one option. So yeah, so we have to overwrite that to in order to change it. Okay. Um, we can't say like A less than B for comparing where strings sit in dictionary order. We can say dot equals to test equality or compare to test where it lands in the dictionary. Other methods, we saw char at. Length is also useful. Like if we wanted, let's print something. If we call string pi dot length, that just counts how many characters are in our string. So 1, 2, 3, 4. So if we run that, we expect 4. There's 4 characters. That just tells you how long it is. Substring, we can get, substring is where we like, it's kind of like slices in Python, where you take, here's like this one part of it, and I'm pulling out and setting it into a new variable. So let's go back to our super long string. So if I wanted to do, let's print my new awesome string dot substring. There's a few options. There's, if I just give a begin index, I can say start here, go to the end of the string, take all of it. Or I can say start here, end before here, and take that way. So I'll do the second one. And let's go, I don't know, characters 3 through to 8. So if I do that, I get low dot dot dot. So yeah. So you'll use the substring in lab 2. Okay. Okay. Any questions on strings before we move on? All right. Actually, let's see. Let's take no. Okay, let's keep going. Sorry. Sometimes I might want to build in breaks, but we've got stuff to do for now. Okay, so who remembers using lists in Python? Great. So arrays are kind of like Python's lists. We use them with the square brackets, just like lists, but they're more strict. So they are also indexed starting at 0. So if we want to like get an item from the list, we got to start counting at 0. The main difference is in Python, you can have a list of like anything. You can have like some integers, you can have some doubles, you can have strings, you can have whatever. But arrays in Java only allow for one type of variable for the list. So I've got this list, it can only contain whatever I define it. So like if I have an array of integers, the only thing in that array has to be integers. Can't have strings, can't have doubles. So it's strict there. And then for arrays, we also can't change the size once they're created. If we do want to change the size, then we have to reassign. We have to make a new array that's bigger and then copy everything over. And it's a bit of a pain. So those are the main differences. So let's try that out a little bit, and then we'll also try yeah, so we'll see some ways we can make it better. Okay, I'm gonna make a new class. I'll call this array test. Okay. Okay, and then I'm gonna make a main method. Okay, so to declare arrays, it's a little bit different. So I'm going to say, I have the type of things that are going to be in the array. So let's say I want an array of integers. Then I need my square brackets open and close. So it can be right next to here. There can be a space there. Doesn't really matter. And then the variable name. There we go. I've declared my array. I could also say, I could also move those square brackets after the variable name. That's also fine. Does the same thing. I think typically you'll see it more like this, which kind of tells us as the programmer, like, hey, I'm going to have an array of integers, and the way I know it's an array is those square brackets are right after the int. But we need these square brackets to say this is an array. It's not just a single integer. Okay, that's step one to declare. Now we have to allocate space for it. So we have to say how many things are going to be in our array. So let's say array 1 is equal to, here's the new keyword again. And then just to be sure, our array is only going to have integers. And then in the square brackets, we say how many integers do we want in here. So let's say I want 100 integers. So now I have allocated space for 100 integers to be stored in array 1. Well, okay, let's try it all in one line. Let's say have a new one called array 3. And I can just set all of these equal to each other, and that both declares and allocates space for my array all in one go. We can also specify the initial values. So let's say I have an array called array 4. I can set up, here's the exact things that I want in my array, and I can do that with curly brackets. And so let's say I want even numbers. So I can say 2, 4, 6, 8, and 10. And then my array 4 has a size of 1, 2, 3, 4, 5. 5 things in it, and it's the odd number or the even numbers 2 through 10. Just like in Python, we can say, let's pull from array 4 because we've got stuff in there. We can use the square brackets once we have stuff in the array. We can use square brackets to access the things inside the array. So if we want to get the second index item, we can put 2 there. And so that would give us 2 is 0, 4 is 1, 6 is 2. So it would give us 6 because remember we were indexed starting at 0. So if we run this, then we get 6 as expected. Okay. So that's the basics of arrays. We're also going to be using lists in Java. There's different types of lists. You'll see me using just general lists and also array lists. I've got array list in my notes, so let's go with that. So for array lists, give us an easier interface. It resizes automatically, which is nice. So we don't have to worry about reallocating and reassigning all of that data. Like arrays, there's only one type allowed. So that's just kind of how it is in Java. We can just have this one type in my list. Okay, so let's see how that works, and then we'll talk a little bit about these other things. So we can have a list. Is this gonna be mad at me? It's gonna be mad at me. Okay. Okay. So, all right, yeah. Okay, so we've got my list. Let me try this again. All right, so we've got array list and then these angle brackets, the less than and greater than symbols. And inside of those, we say, here's the type that's going to be in my list. So for int, we say capital I integer. It's important that it's not int. That the difference here is important. That goes back to reference types and primitives. So it's expecting a reference type, and so we'll just give it capital I integer. So the type of thing that's going into this list is going to be in those angle brackets. And then we say new array list, and then we repeat those angle brackets. And then we've got the open and close parentheses to call the constructor. You may be getting squiggle arrows, red squiggle line under here. That's because it doesn't know what array list is. We can tell it what we want. So if we hover over this, then we go to quick fix. Some things pop up here. Options are like to create a class for array list or an interface. But it's already defined for us. Java defined it. So we want the one from Java util. So we import the array list from java.util. If I clicked that, then up here, now we've got import java.util.arraylist. That's what we want. And so to fix the list, I'll do quick fix, also import list. That can be mad at me. Sorry. Okay, that's not working for now. That's fine. I'll just comment that out. Okay, so we've got an array list and we can do stuff with this. We can add things. So let's say mylist.add. Let's actually do this in a for loop. So let's say for int I start at 0, I is less than 10. And let's add, I don't know, all the even numbers. So we'll add I. And so I can print the list as well. So we've added 0, 2, 4, 6, 8. And then if we print it, it gives us 0, 2, 4, 6, 8. Instead of doing something like my list and then the square brackets, like if we want the third index item, that doesn't work with array lists. In order to do something like that, we have to say, mylist dot get. So if I can say get the item at position 3, then that works. If we print it, then we get the item 6. Okay, so we've got get. We've got add. So get takes it gets an element in the list, adds an element to the list it appends to the end. Let's look over here. We can also set a value. So like if we want to set the element 3, so that's 6, if we want that to be 7 instead, we can say, let's add it here, mylist dot set index 3 elements as 7. So we want to, instead of 6, we want it to be 7. And let's print my list again to make sure. So it should be 0, 2, 4, 7, 8 instead. Plus, and there we go. So we can use set to replace an element in our list. And if we didn't allocate anything, it'll just, if we add too many, it'll just resize it automatically and do that for us, and we don't have to worry about it. Okay. We can make lists 2-dimensional. We can also make arrays 2-dimensional if we want to. The way that looks is I'm going to have an array list. The type of things in my array list are array lists of integers. So that's how I can set up, like, I can have a 2-dimensional, so like a list of lists. And then each thing in that list is a number. So that's how I can set up something 2-dimensional. Okay, so we're going to talk about for each loops now that we have something that we can iterate through. So now that we've got a container, like a list, an array, or a string, we can navigate through that with the for each loop, where we still have the word for, and then we're going to say, here's the type of thing that we're working with here. Here's what I'm going to call each individual thing in this container. And then I have the colon, and then I say, here's what the collection is named. So let's try to go through my list and I don't know, let's just print it for once. So let's say we want to print everything in my list on its own line. So I can say for, so there's snippets here. I could type it all manually, or I could choose one of the snippets. So I'm looking at a for each loop. So if I say for each and press enter, and it wrote this for me. So it says integer, and then it has a name, lowercase I integer, and it says my list. I could also, sorry, this thing keeps popping up. I could also say int I, not capital I, lowercase I. But the idea is on the left-hand side of the colon, this is the type of thing and what I'm going to call each individual one. And on the right-hand side of the colon, this is the thing that I'm navigating through. So I'm navigating through the collection called my list. So here I'm going to print I. Maybe I want to print the double of every element in my list. So I times 2. That's possible. And so what are we expecting from that? 0 times 0, 0 times 2 is 0. 2 times 2 is 4. 4 times 2 is 8. 7 times 2 is 14. 8 times 2 is 16. So if I run that, then I get 0, 4, 8, 14, 16. So this is a for each loop where we have the parentheses, but the inside the parentheses is structured a little bit different than just the I equals 0, I less than whatever, I plus plus. So it allows us to navigate containers instead of just doing things by like integers. Okay. Any questions so far? Okay. All right, so I think I'll have the yeah, okay. So I'm going to have you guys work on this. Okay, let's make a new class. I'll call it length of strings. And I would like you, so we're gonna have a main method and we're going to add a bunch of strings. So I'm gonna add like hello. Oops. My name is Sarah. So I have a bunch of strings that I'm adding to this list. And then your job is to write a method. So the signature looks like public static int. I'll call it count chars. And its parameter is going to be an array list string, an array list of strings. And your goal is to return the total number of characters in A with a for each loop. You can use the char at method. And that, yeah. And so you're going to return something. Okay, so we've got about 7 minutes until the class is done. So work with partners, and this will be your active learning for today. So work with a partner, get this code, get this method working, and you'll be good for the day. Okay, I'm gonna edit the active learning real quick. All right, so we'll work on this for the rest of class. I'll walk around, see if you have questions. And we'll be good to go.